Hi, Assalamualaikum. My name is Muhammad Adam bin Kamal, and today I will be present my proposal on the development of off-grid stand-alone portability system, also known as OGP or SAPV. This project is part of BELS Datum 1425 course under the Faculty of Electrical Engineering Technology at University Technical Malaysia Melaka. Solar energy is one of the most important renewable energy sources in the world today. In Malaysia, we are very fortunate because we receive a high amount of sunlight throughout of the year, with an average solar radiation of about 4.5 to 5.5 kilowatt hour per meter square per day. Because of this, solar energy is highly suitable to be developed in Malaysia. In particular, off-grid solar systems are very useful in rural or remote areas where access to electricity from TMB is not affordable. An off-grid photovoltaic system is standalone system that operate independently without any connection to the utility grid. This system use solar panel to generate electricity and store the energy in battery for later use. It allows users to have continuous electricity supply even in locations where there is no external power source. The main objectives of this project are first to design an off-grid or solar PV system suitable for a rural house. Second, to calculate the required system size based on daily energy consumption. Third, to select suitable components such as solar panels, battery, and inverters. Fourth, to analyze the reliability of the system. And finally, to consider professional, social, and ethical aspects in the design. For this project, the proposed system is designed for a small rural house. The system is intended to support basic daily electricity needs such as lighting and ceiling fan, television, and phone charging. The focus of design is ensure it is simple, affordable, and reliable for users in rural areas. To begin the design, we first calculate the total daily energy consumption. The lighting system uses 150 watt per day. The ceiling fan uses 600 watt per day. The television uses 400 watt per day, and phone charging uses about 60 watt per day. So the total consumption for the system is 1210 watt per hour per day. To determine the required solar panel size, we use the formula based on the calculation. The required power is approximately 322 watt. However, to ensure better performance and to account for system losses, we select we select to better performance and for account for system losses, we select a 400 watt solar panel for this design. Next, we calculate the battery size. The battery size is important because it stores energy for use during night time. or cloudy days. Based on calculation, the required capacity is around 200 ampere hour per hour. Therefore, we select a 12-volt 200 ampere per hour battery for this system. The main component of this system include solar panel, a charge controller, a battery, an inverter, and the electrical load. Each component plays an important role in ensuring the system works efficiently and safely. The slide shows the system layout. First, the solar panel generates direct current of the DC electricity. Then, the charge controller regulates the voltage and current to protect the battery. Next, the energy is stored in the battery. Finally, the inverter converts the DC electricity into alternating current or AC electricity, which is used by household appliances. The solar panel used in this design is 400-watt monocellular type, which was high efficiency. The battery is a 12-volt 200 ampere per hour deep cycle battery. The inverter is a 1 kilowatt pure sinks with inverter, which is suitable for household appliance, and the charge controller is 40 ampere MPPT type, which improves system efficiency. The system has several advantages. First, it does not depend on electricity grid. Second, it uses clean and renewable energy. Third, it helps reduce electricity costs. And lastly, it requires relative low maintenance. In terms of professionalism, the system follow guidelines from Suruhanjaya Tenaga. It also complies with Malaysia standard and AIC standard for solar PV system. Proper installation method and safety practice are considered to ensure reliability and user safety. The system contributes to society and providing electricity to rural areas where access is limited. It improves the quality of life for users. At the same time, it reduces dependence on fossil fuels and supports sustainable development. One of the main challenges of an off-grid system is lack of sunlight during rainy or cloudy days. To overcome this issue, the system uses battery storage and slightly oversized solar panels. In some cases, a backup generator can be also used an additional power source. The estimate cost of this system is around 3,500 Malaysian ringgit. This includes the solar panel, battery inverter, charge controller, and installation cost. This cost is considered reasonable for a small off-grid system. In conclusion, the proposed off-grid solar PV system is a practical and suitable solution for rural areas in Malaysia. It provides the reliable electricity, reduce environment impact, and support of user of renewable energy. Thank you for your attention. That all from me. If any question, I will happy to uh thank you.